When selecting a cable for the primary side of a 1500 kVA transformer with a 277/480 volt secondary, several factors must be considered to ensure safe and efficient operation. These factors include conductor size, cable type, conductor stranding, and cable jacket. According to the IEEE 841 National Electrical Safety Code, the minimum conductor size for a 13.8 kV cable supplying a 1500 kVA transformer is number 2 AWG stranded aluminum. This recommendation ensures that the cable can safely handle the anticipated current load without overheating or causing excessive voltage drop. The recommended cable type is cross-linked polyethylene, abbreviated XLPE, insulated medium voltage cable. XLPE insulation offers excellent electrical properties, high temperature resistance, and resistance to moisture and chemicals, making it suitable for medium voltage applications. For maximum flexibility and current carrying capacity, the conductor should be concentrically stranded. Concentric stranding arranges the individual strands of the conductor in a uniform, circular pattern, minimizing air gaps and maximizing the conductive surface area. The cable should have a thermoplastic or thermosetting outer jacket for protection against moisture, abrasion, and sunlight. These jackets provide a durable barrier against environmental factors that could degrade the cable insulation and compromise its performance. In addition to these basic considerations, several other factors may influence the selection of the appropriate cable size and type. Firstly, the actual cable size may need to be increased based on the specific voltage drop and ampacity requirements of the installation. Voltage drop refers to the reduction in voltage that occurs along the length of the cable due to its resistance. Excessive voltage drop can negatively impact the performance of connected equipment. Ampacity refers to the maximum amount of current that a cable can safely carry without exceeding its temperature rating. Secondly, the cable should be installed in accordance with the manufacturer's instructions and local electrical codes. These codes provide detailed guidelines for cable installation, including requirements for conduit, burial depth, and termination methods. Proper installation is essential for ensuring the long-term reliability and safety of the cable system. Thirdly, consider the ambient temperature and soil conditions when selecting the cable insulation and jacket type. High ambient temperatures can reduce the ampacity of the cable, requiring a larger conductor size. Soil conditions can affect the rate of heat dissipation from the cable, influencing the choice of insulation and jacket materials. When performing cable sizing calculations, it's important to use the appropriate formulas and tables provided in the National Electrical Code, specifically Article 310. These resources provide guidance on determining the minimum conductor size for various applications based on factors such as load current, ambient temperature, and installation conditions. The National Electrical Code, or NEC, provides specific tables for ampacity correction factors based on ambient temperature. For example, if the ambient temperature is higher than 30 degrees Celsius, which is 86 degrees Fahrenheit, a correction factor must be applied to reduce the allowable ampacity of the conductor. These correction factors can be found in NEC Table 310.15. The NEC also addresses ampacity adjustment factors for the number of current carrying conductors in a raceway or cable. When multiple conductors are installed together, the heat generated by each conductor can raise the overall temperature, reducing the ampacity of each individual conductor. Adjustment factors are applied to account for this effect, and these can also be found in NEC Table 310.15. When selecting a cable, it is also critical to ensure that it is properly rated for the voltage and current requirements of the application. The voltage rating of the cable must be equal to or greater than the system voltage. The current rating, or ampacity, of the cable must be sufficient to carry the maximum anticipated load current, including any applicable safety factors. To reiterate, for a 13.8 kV system feeding a 1500 kVA transformer, the minimum conductor size is generally number 2 AWG aluminum. However, this is a starting point, and the actual size might need to be larger based on calculations and the factors previously mentioned. These calculations include voltage drop and ampacity rating based on installation conditions. Always consult the NEC and local codes for specific requirements and use qualified personnel for installation and terminations. Remember that the type of cable should be an XLP insulated medium voltage cable. XLP provides excellent electrical insulation and is suitable for the voltage levels in this application. Concentric stranding is the preferred conductor stranding method for flexibility and current carrying capacity. Finally, ensure the cable has a suitable outer jacket for protection against environmental factors. Always consult with a qualified electrical engineer to ensure that the cable selection meets all applicable codes, standards, and project-specific requirements. Proper cable selection is vital for the safe and reliable operation of the electrical system.